Yes, hello, you're most welcome to my YouTube channel. Having been hit by COVID-19, now learning and teaching have become very, very, very tricky in a country like Uganda. But we always have solutions alongside. And this is your teacher, Peter Ikaja, going to take you through a very, very technical and essential topic in pure mathematics. That topic is called differentiation, but we're basically going to look at the derivatives of trigonometrical functions. Of course, this requires you to have ideas of the previous differentiation. That is the differentiation that we normally introduce with, especially when you are just in senior 5. Now, I'm now going to go on. Having covered trigonometry, you should now be able to also differentiate trigonometrical functions like sine, cosine, tan, sec, cosec, and the others. Without wasting a lot of time, we are going to make it in a summary form, but the main point will still be stressed out, and you have to make sure you follow the steps very well, and make sure you pause the video in case you want to write down something. Okay, so without wasting time, we are going to begin the differentiation from first principles. So we shall do all this from first principles. Now, first principles will help us to get the origin. It will help us to get the origin of how the derivatives of all the trigonometrical functions we're going to be considering come about. I am going to begin with a very simple one, and that is going to be, for example, sine x. So I will say, e.g., if I've told you to differentiate, differentiate sine x from first principles. Differentiate sine x from first principles. That is what we're going to begin with. There we are. So if you are told to differentiate sine x from first principles, number one, you need to remember the knowledge that you already had for differentiation from first principles. Except that in this case, we shall make some few assumptions that will be a little bit unique and different from the ones we have been making. But some other assumptions will actually be similar to the ones we have been making all along. So we could write this question down, and then we can begin the calculation together. So we shall say in our solution, let y equal to sine x. Now, after taking y to be sine x, we are going to simply take a small change in y and also take a corresponding small change in x. What will this mean? It will mean we shall have y plus delta y, or the change in y, is equals to sine of x, but plus the change in x. So you take a small change on the angle, because our angle is x. Then we make delta y the subject. So delta y becomes sine of x plus delta x minus y. But remember, your y is equals to sine x. Your y is equals to sine x. Then from this level, we are going to borrow some simple knowledge from what we call the factor formulae. Remember, the teachers gave you most of these formulas, and now we are going to simply apply one of them, especially when we have a sine of a given angle minus a sine of another angle. Automatically, we shall say that delta y is going to be 2 cos. So I'm going to add this plus this angle, divide by 2, so it will be x plus delta x plus x divided by 2. Then sine, I now get this angle minus this angle. So I will have x plus delta x minus x, but also divided by 2. So when I do this, I will end up with 2 cos, remember I have x plus x, which is 2x, and that gives you 2x divided by 2, which gives us x, Then we remain with plus delta x, but remember delta x will still be divided by 2. Then from this point we can see x cancels with x, so we remain with delta x out of 2. So it means we remain with sine delta x out of 2. Then now one assumption we're going to bring in here is that for small angles, for very small angles in radians, sine delta x out of 2 is as good as delta x out of 2. So I will say for small angles, sine of delta x out of 2 is approximately, or it tends to, delta x out of 2. That is only on condition that the angle is very small. So this leaves us with delta y is equals to 2, the 2 we have here. Now the whole of this, remember, is now approximated delta x out of 2. So it means I will have times delta x out of 2. Then you remember that we have cos of x plus delta x out of 2. There we are. Then if you can look at this, we shall have the 2 cancelling with the 2. Then it will imply that we have delta y is equals to delta x cos of x plus delta x divided by 2. Then from this level, we shall simply divide both sides by delta x. And so when we do so, we shall have this by delta x, this side by delta x. So we can see that this delta x and delta x can cancel. So that remain with delta y out of delta x is equals to cos of x plus delta x but divided by 2. Then from this level, we're now going to bring in the last assumption. And that assumption is going to be in limits as delta x tends to 0. Delta y out of delta x tends to divide the x. So we shall say as delta x tends to 0, comma, delta y out of delta x tends to will tend to divide the x. Tends to divide the x. Now what will this tell us? This will automatically tell us that if delta x is already tending to 0, this will all be 0, so it remains with x. Meaning that in conclusion, that dy dx will actually be cos of x. It means dy dx will be cos of x. So this is something that you have to take so serious. From today onwards, you should know that when you differentiate sine x, you will get positive cos x. That is going to be our first derivative. We shall now move on and also look at the derivative of cos, look at the derivative of tan, and many others. Then I think I'll leave you with a few after giving you all the ideas that you need for you to also try out. Okay, so question 2 says differentiate cos x from first principles. Of course, in this case, remember, we're doing the differentiation with respect to x. That is something we need to remember keenly. So we shall again say let y equal to cos x. After that, we shall take a small change in y, as we also do the same on x. So we shall have cos x plus delta x. From this point, we shall make delta y the subject. So that delta y becomes cos of x plus delta x. But remember, it would be minus y, which y is already cos x. Y is already cos x. Then from this level, you are going to realize that now we again have cos minus cos. But in factor formulae, when you take up one of the formulas where you have cos of a given angle minus cos of another angle, it becomes negative 2 sine sine. So I will say delta y is now going to be negative 2 sine. I added these angles together, x plus delta x plus x divided by 2. Then I subtract sine of x x plus delta x minus x divided by 2. So that is what I will have for that first case. I have applied what we call the factor formula. So in this case, delta y now becomes negative 2. If you can see this, it is going to be x plus x again, which is 2x, but divided by 2 you get x. So I'll have negative 2 sine of x, but remember there is delta x here, and so it will be remaining as delta x divided by 2. Then in this case we have x minus x cancelling, then delta x out of 2 will be the remaining function in that case, sine of delta x divided by 2. Again, we make the same assumption here, that for small angles in radians, sine of delta x out of 2 is approximately delta x out of 2. So you have to clearly show those assumptions. I'll say for small angles, sine of delta x out of 2 tends to delta x out of 2. So it means we shall have delta y is equals to minus 2. Now instead of sine delta x, I'm going to have delta x out of 2 because of this assumption here. Then I drop it at the back here, so that I have times delta x out of 2. But remember, I still have my sine. Have my sine x plus delta x, but out of 2. Then from this level, you can see that the 2 can cancel with this. This time we remain with the minus sign. We can't ignore it. So it means delta y will be minus delta x, but sine of x plus delta x divided by 2. The next step from this point is going to be dividing both sides by delta x. So dividing means we are going to have this by delta x and also divide this by delta x. So that we have delta y out of delta x giving us minus sine of x but plus delta x divided by 2. Then from here we make the last assumption, and that is as delta x tends to 0, delta y out of delta x will be tending to divide x. So it means I will have to say as delta x tends to 0, as delta x tends to 0, comma, delta y out of delta x tends to dy dx. Please, the assumptions has to be clearly stated. Do not ignore them in any expression. So it means as this happens, it means now dy dx will become, I have a minus here, delta x out of 2 is now going to be approximately 0. So it means I'll have minus sine x. I will have minus sine x. So what does it tell you? When you differentiate cos of a given angle, say x, you will get a minus sine of that angle. When you differentiate sine, like we began with, you get positive cos. But when you differentiate cos, you get negative sine. That is something to note with care at this level. Let us now move on to question 3 and look at a more complicated trig function, and that is going to be tan of a given angle. And then later, I will give you trials, especially for sec, cosec, and cot of x. Okay, so let us look at question 3. They're telling us to differentiate tan x from first principles. This time we are very specific with respect to x. WRTX means with respect to x. So what shall we do? Shall again follow the same principle. So we shall begin by saying let y equal to tan x. But remember, tan x is as good as sine x out of cos x. So we shall express it in that form so that we have sine of x divided by cosine of x. That is going to be the first step. The next step is now taking a small change on y. So I will have y plus delta y giving us sine of x plus delta x. All this divided by cos of x plus delta x also. Then the next step, of course, as usual, we shall make delta y the subject. So it means delta y now becomes sine of x plus delta x divided by cos of x plus delta x. All this minus y, but y is sine x over cos x. So I will say sine x over cos x. Now, this time round, we may not apply the factor formula. It is going to be a special case. We are simply going to look at what we call the application of compound angles. But again, before we do that, we have to first get the LCM of this, simplify, then we can see which identity from compound angles we are going to put in application. So it means delta y is going to be, if I take the LCM will be cos of x plus delta x. Make sure you capture those two angles in a bracket, then cos of x. And I say, of course, if I have this divided by this, I'll get cos x. So it will be cos x by this. So it means I will have sine x up plus delta x, but cos x. Minus, because I have a minus here, I will now have cos x plus delta x. I've just got the LCM here, then sine x. Now from this level, when you look at the upper part, we have sine cos, cos sine. But the sine of the angle here, our angle is x plus delta x, and in this case it was cos of that very angle. Cos of x, sine of x. So when you get back to compound angles, we shall derive it from the identity sine of A minus B is equals to sine A cos B minus cos of A then sine of B. If you recall this identity from your trigonometry, that is under compound angles, it is what I'm going to apply here. How will I apply it? Now our A is going to be x plus delta x, and my B will be x. As simple as that. So it means I can summarize the whole of this, the whole of the numerator by simply writing sine. I'll say delta y. Delta y is equals to sine of x plus delta x. Remember, this is our A. Then x is going to be our B, so I will say minus x. Because I said we're using A minus B. So when you compare, A corresponds to x plus delta x and B corresponds to x. All this divided by cos of x plus delta x, then cos of x. And when you look at the upper part, the x can now cancel. So it means we remain with delta y is equals to sine of delta x. All this divided by cos of x plus delta x, but cos of x. Cos of x. Then as you can see this, we are now going to make an assumption. Because we shall say, for small angles in radians, sine of delta x is approximately delta x itself. That is for small angles in radians. So I'm going to be rubbing this because I don't have more space. Then we can add on this and complete. So I am sure you followed those steps clearly. Allow me rub and we put the next step. Okay, so from our last step down here, we shall now say for small angles, what do we know? We know that sine of delta x will tend to delta x. Sine of delta x tends to delta x. So it means we have delta y is equals to delta x divided by cos of x plus delta x, but into cos of x. So from this level, what can we do? we can now bring in the last assumption. And the last assumption is the one in limits. We know that in limits as delta x tends to 0, comma, delta y out of delta x tends to dy dx. Tends to dy dx. So what does that mean? It means we have delta y. I beg your pardon here. I beg your pardon. Before we do that, we shall first have to divide by delta x on both sides. And dividing this by delta x means I multiply by 1 over delta x. And I can see that this will cancel with this before we bring this assumption here. Sorry for that. It means shall have delta y out of delta x is equals to 1 divided by cos of x plus delta x, then cos of x. Then now we say as delta x tends to 0. What do we expect? We expect delta y out of delta x to tend to dy dx. We expect that to happen. And if it is true, then it means we shall have dy dx. Dy dx now becomes 1 divided by cos of x times cos of x. And this comes to 1 over cos squared x. But we all know that 1 over cos squared x is the same as sec squared x. So this becomes sec squared x. And that will be our dy dx. Now what does it mean? It means that right from today, we should know that when you differentiate tan x, you get sec squared x. Now I am sure you've now got the ideas for differentiating sin x, cos x, and tan x. Now when you know how to differentiate sin x and cos x, then you can't fail to differentiate cosec x and sec x. But you make sure you express sec x as 1 over cos, then cosec x as 1 over sin x. That is when you will apply the factor formula again. Then when you go to cot of x, the idea is going to be as good as the one we have used to differentiate tan x from first principles. So my assignment for you today is to try out differentiating sec x, cosec x, and probably cot x. And that will be what I will find out in our next tutorial. Otherwise, for now, I think this has been a good enough lesson for you to start on building the knowledge of differentiation of trigonometrical functions. Remember to share this link of this YouTube, share my link of the YouTube to friends around, even if you have friends in any part of Uganda, out of Uganda, as long as he or she is interested in understanding the mathematics that is specifically differentiation of trigonometrical functions. Feel free to share with them, and I'm sure they will also have to be encouraged. Remember to also subscribe, because when you subscribe, you will always be updated whenever I upload new content. You will always receive a notification that Kaja Peter has uploaded new content. Please, thank you for giving the best audience. See you again in the next tutorial.